start recording. And talk about will be power of compounding. All right, David. All right. So when we look at simple, what we're going to call simple interest, and compare that to compound interest. First thing, compound interest is going to make you more. Right? You're going to earn more if you're doing it compoundingly. So let's just start off with a few definitions. Talk about principal. So when we talk about the principal, that is the amount of money you invest. Right? That's where you start. Usually designated in a formula with a capital P. The principal is the balance on which interest is paid. All right. So that's how your money earns money. All right. You want to compare simple interest is paid only on the original investment.
I think your marker ran out of ink. It's not writing. Oh, now it showed up. Never mind. I was invisible for a minute.
So you're okay? You can see it now?
Yes.
Okay. Is paid only on the original investment and not on any interest added at a later date. So what we're basically saying is if I put $1,000 and let's just shoot the moon here and say, oh, I've got an annual simple interest rate of 10%, just good round numbers. Then I'm going to be every year earning $100, 10% of 1,000, and so that would be the interest paid. But the year two, I would actually start in my account with 1,100 because I would have added on my interest earned for that first year. But the second year, I'm still just getting 10% of my original investment or the principal. And so that's what simple interest is. So if we compare that then to compound. So compound interest is interest paid both on the original investment and on all interest paid, not paid, we could say paid, but I'm going to take that word out. On all interest that has been added. To the original investment. That's a B. Best. So in my little simple example of $1,000 and ridiculous, what we will end up calling APR, annual percentage rate, of 10%, then that, and let's just say we were compounded annually. And when you hear the word annually, that means a year. So then the way it would work is simply you would earn $100 in that first year, but the second year it's now going to be 10% of $1,100. So, and then so that's what compounding means. All right. So just kind of getting those terms out of the way, and then starting to get into the mathematics of this. So, and I'm going to put an email out. Mentioned it a few times. You're going to need, you can use a scientific calculator for this, but it can become difficult. And when we get to what's going to be called continuous compounding, which involves the number E, and yes, that is a number. All right, so it sounds crazy, but it's like pi. So we're all familiar with pi. You know, we write it here. It's an irrational number. In decimal form, never repeats, never terminates. We now designate March of 14 as Pi Day, 3.14, right, approximately to hundreds place. Well, when we deal with continuous compounding, we have to deal with a number called E. And it is also irrational. So in decimal form, it never repeats, never terminates. And it is approximately, depending on what to say, there we go. Yeah, if you round in hundreds place, it's 2.72. And now trying to talk about exactly where, because pi is kind of easy to talk about where it comes from. Everybody can kind of wrap their head around it. It's crazy, but it is true. For pi, it is actually a ratio of a circle, any circle of any size. And you have what's called circumference. That is, if you measure all the way around the circle, and then what we call diameter of the circle, which is a line which goes from one end of the circle to the other, goes through the center. Anyway, if you take any circle's circumference and divide it by its diameter, it comes out as pi every time. So we call it one of the universal numbers. We could travel the breadths of the universe and find another intelligent civilization, and they would have different symbols and different numbers and whatnot, but circles would still be circles, whatever they were called, they're still circles. And a circle's ratio of its circumference to its diameter would still be pi. It comes from another kind of crazy looking formula, and it ends up being what's called its horizontal asymptote of a particular function. And this horizontal asymptote is exactly this number E. Now, you don't need to remember any of that other than there is this number E, and it's about 2.72. And you can find it. So I'm going to try to hold this up, and I'm going to write this down at the end and send an email. It's called, it's a Texas Instruments calculator, TI-30XS, and it says multi-view right underneath the TI-30XS. Depending on where you pick it up, you're not going to spend any more than about 20 bucks. All right. Now, Texas Instruments TI-84 runs you about 120. So, definitely much more pricey. Now, if you're going to be in a STEM program and take a lot of math courses, then the 84 is the way to go. But this little calculator, again, very inexpensive. But it has the ability to, it has the number E on it. I've actually kind of popped it where you should be able to see the screen where I have E to the first. And you can see the 2.718281828, etc. But you will need a calculator that has E when you do the continuous compounding problems, for sure. And secondly, you're able to put the whole formula in here one shot and hit enter. Whereas with a scientific calculator, you can't round very much. You have to put a lot more effort. So it is in our bookstore. We keep these stocked. And again, with their markup, it's around $21, I think, somewhere in that neighborhood. So,
yeah, it was 21.48.
Yeah. So, I mean, if you have your phone and your phone has a calculator which has the number E, you're good to go. But it does. It is not. You're not able to put the whole formula in on a phone calculator because it operates like a scientific, which means it has an equals button and not an enter button. All right. So with that said, let's start to look at the different kinds of formulas we will be looking at with interest. All right, so let me turn the page. And I'll just call this the compound interest formula. And again, specifically for interest paid once a year. All right. So here it is. A, capital A, equals P times, and we're going to have a quantity, two things added together inside the parentheses here, 1 plus APR, capital A, capital P, capital R, and then to a power, exponent, and that is a capital Y. All right, so what do the parts mean? A is accumulated balance after Y years. Right. So Y is obviously going to be the number of years. So Y is, I'm going to use the pound sign here, number of years. APR, capital A, capital P, capital R. This is what we call your annual percentage rate. And you put it in the formula in decimal form. So when you'll get, you get, whatever the percentage rate is, and it'll be as a percentage. You'll move the decimal place twice, get it in decimal form, and that's what you'll pop into the formula. All right. But that's like in my simple little problem, and I said, 10%. You can find a return of 10%, an APR of 10%, jump on it. I've never seen it. But, and then P, as we had mentioned before, is your principal. So your starting principal. All right, so meaning the way it works in the formula, you would put in, how much you want to invest, say $5,000. Let's say it was at a 3% APR. Then you would put 0.03 right here. And let's say you wanted to know the amount of interest earned after 5 years. Then you would put 5 up here in the exponent. And then you would just do the arithmetic, and A would come out to be how much money you would have earned over that 5-year period. All right. So, fair to say here, the other terms, you will sometimes hear principal referred to as your present value, and A is referred to as your future value, how much money we're going to earn over a specified period of time. Okay. All right. Now, I'm going to try to go right here. Do a little simple example. Let's say I'm going to invest $100. That's going to be my P, my principal. And let's keep it crazy. And let's say I have an APR of 10%. And what I want to compare is, let's say we put it in one account over a 5-year period. So Y would be 5 years. And this is going to pay simple interest. Now, so remember, if it's simple interest, if I do simple interest, let's put this one here. So if I go with simple interest, then that means every year I get a flat rate return that is simply whatever my original investment was times the APR in decimal form. So that would be 100 times 0.1, which is $10. And so over a 5-year period, I would just keep adding $10, which means after end of year one, I would have $110. End of year two, I'm just adding in again $10. So I'd have 120, and so on and so forth. So I got to my 5th year, into my 5th year, and I would have $150. That is, so if I just had what was called simple interest. Now, I said already, if you use compound interest. Now, remember what would happen is, at the end of the first year, in a compound interest situation, you would still, at the end of the first year, have $110. You would have earned 10% on your original investment of $100. So you would, at the end of year one, you'd have 110. But the difference is now I'm going to go 10% of 110, and then add that, to get my end of the year two. So end of year one, you would have $110. But now you're going to go 110 times 0.1, which is 11. And so at the end of year two, you would actually have $121. Notice that's $1 more than the simple interest situation. And you would continue then. So to get the end of year three, you'd be multiplying again 0.1 times 121, which comes out to about $12.10. And anyway, up to year 5, which you would end up now with 151.05. And you would say to yourself, well, is there a huge difference? It's a what? $1.05 more. But it's more, period. So you want to compound. And we'll find the more times you compound, the more money you're going to make. All right. So right now we're just looking at annual compounding. Now I'm going to attempt to now put this in the calculator. So we said $100, and that would be times 1 plus 0.1, and then to the power of 5. You said 5 years, right? Oh, my bad. I can't read my own writing. That was a 6. Got to clarify when I looked at the calculator. All right, so I'm going to hold up my calculator. I just put it in. All right, everyone see it now? So you can see I just actually put the numbers in the formula. 100, and then you can see where I put the parenthesis. 1 plus 0.1, my interest rate, close, and then that caret symbol you see, that little kind of pointed arrow there in the exponent, it's called a caret, and there's a button right there on the keypad that raises power, so 5. Now, so out it just spits, without having to add the interest in every year. It would tell me my accumulated value is now 161.051. So it's actually $10. Can't read my writing. Actually, I guess $11.05 more compounding it annually as opposed to simple interest. All right. Um, so let's turn the page and talk about compounding more than just once a year and how that might look. So another formula that'll be very similar to the first one we started with, but there will be some difference. So we'll look at a compound interest formula. For interest paid in times per year. And I'm sure these are things you have heard, different situations. I've got this APR and it's compounded quarterly. That means 4 times a year you're compounding. Or compounded monthly, compounded daily. And then again, there's what's called, we'll get that at the end, what's called continuous compounding, which means it's actually compounding infinitely many times a year, which kind of sounds crazy, hard to wrap your head around that, but that is what it is. So formula looks like this. Your accumulated money here equals P, right, times. All right. Now remember, but in here was just 1 plus whatever your APR in decimal form. This is going to be 1 plus APR divided by the number of times you compound within that year. So yeah, it would be great if you could take whatever your APR was and then, said, yeah, I'm going to compound it 4 times. So the amount of money I have in your times 0.04. That's not how it works. It actually would take the 0.04 and divide it up. If you did it 4 times in a year, divide it by 4. So that compounding is going to have a fourth of whatever the APR was each time within that year. But you simply would put in your APR and you would divide it by the number of times it's going to be compounded in that year. And then to the power up here, the number of times it compounds in a year times the number of years that you have it in the investment. And so everything is the same as the previous formula. That is, A is your accumulated balance, P is your starting principal, your APR is your annual percentage rate as a decimal. And Y is still years. So everything is the same. We'll put with in is going to be the number of compound periods in that year.
Under the APR, is that just like a little frown or symbol of quarterly?
I'm sorry, say that one more time.
Underneath the APR in the fraction.
Oh, so that is divide by N.
N, okay. I
Yeah.
wasn't sure if it was just a sad
Gotcha.
face.
Nope. No.
Thank you.
So, yep. And that's where I was, from the previous formula, I'd already written out what every part of it meant and what it was called. So all that is still the same. The new thing we put in here is that N, and it occurs twice in the formula. Once where inside here, I divide whatever the APR in decimal form is by N, and then up in this exponent, it's N times how many ever years you're going to have it in that investment. So N is just simply the number of compound periods per year. So again, if it was quarterly, your N value would be 4. If it was monthly, your N value would be 12. If it was daily, your end value would be 365. Make sense?
Okay. Yeah.
Okay. All right. So let's take a look and see how this might work. So example here, let's say I deposit $5,000. So my principal will be $5,000. I've got an annual percentage rate of 3%. And it compounds monthly. All right, so I'm going to be compounding monthly. And so we would, well, how much money am I going to make? Or not how much money, that would be the interest earned exactly. But let's just say how much money would I have total in this investment after 5 years? So how much dollars after 5 years? All right. All right, so that is what's trying to find A. So putting everything just simply in our formula here, I would have 5,000. You don't have to put the multiplication symbol. We understand if there's nothing there, it is multiplication. It'll be 1 plus, APR was 3%, so it's a decimal, that is 0.03. Move the decimal place twice. And I'm going to divide this by 12 because I'm compounding monthly. And then up in the exponent, I'm going to be n was 12 again. So put a little parenthesis here, 12, and then it's over 5 years. So 12 times 5. All right. So then I'm going to go ahead and again, the nice thing about this calculator is, I mean, if you just use a regular scientific calculator, you're going to have to first go 0.03 divided by 12 and try, you know, if it lots of decimals, I would take it out 5, 6, 7 decimal places. So you don't get round off there. And then you would have to add 1. And then you've got to raise that to this power. That is to the power of 60. And then multiply that result by 5,000. So multiple steps order of operations. This allows me to just type in, I would hit 5,000. I would hit parentheses. Parentheses are right there above the 8 and 9. Kind of like on a keyboard. Then 1 plus, and then I can literally, so I hit the plus button, and then I hit just 0.03 and I hit divide by 12, and then I close parentheses. The machine will sort out the order of operations for you. Then I hit the caret key, the exponent button. Now, you can right there hit parentheses and hit 12 times 5, or just 12 times 5 is what, 60. So I'm just going to put it in as 60 and hit enter. All right. And so, there you go. What we would have, rounded to hundreds place, since we're dealing with dollars, cents, 5,000 and what, 808.08. Boom, done. So it's really just putting it into the formula and crunching it out. Any questions thus far? Good. Okay. Now, So just to differentiate, and let's just say we do the same problem, but we only compound it annually, once a year. Same problem, but only compounded for once a year. So still over 5 years, still your same APR, same principal. Then in that case, so I'll put here compounded. Compounded once a year. And I'll drop that down just a little bit. So in this situation, if it's just compounded annually, once a year, then you would have your 5,000, and it would just be 1 plus 0.03. And the n is now 1 because it's just going to be compounded once in that year. And then your power here would just be 5. Well, that comes out to $5,796.37. And so what we can see is, for sure, the more you compound, the more your money you're going to earn. So, all right. Now you will have a few problems that we'll talk about APY, not APR, but APY. So let's define that. Annual percentage yield. And again, we'll refer to it as APY. All right, so it's a percentage, what we call a relative number. But it gives us how much money I make in terms of a percentage. So you will also hear it called the effective yield, or simply just the yield. Okay, so it is the actual percentage by which a balance increases in 1 year. So if you're compounding annually, then your APR and your APY would be the same. It's going to be greater than the APR if you compound more than once a year. The APY will be. So how do we, again, we've been working with percentages a good bit. Nothing mathematically changes. So as an example, if you had $1,000, so that's your principal, an 8% APR, And let's compound quarterly, which is going to mean that your N would be what, 4. All right. So after 1 year, if we compounded quarterly, you would have what, 1,000 times 1 plus 0.08 divided by 4. And then up here, and we're just figuring up for that first year. We're doing this on an annual basis. So 4 times 1. Y would be 1, N is 4. All right. So that should come out to about 1,082.43. I'm going to punch the numbers in my calculator. 1 plus 0.08 divided by 4, close to the power of 4. Yep. And so that's going to be $1,082.43. All right. Now, so if I wanted to know my relative increase, then that would be what we call our absolute increase. That would just be how much actual money did I make. That is the 1,082.43 minus 1,000. That goes up in the numerator. And so that would be what, $82.43 earned in that year, divided by my starting principal, which was 1,000. And that's going to come out to 0.08243, which as a percentage then would be 8.243%. And that would be, again, in this example, what I call my APY, my annual percentage yield. So it's percentage. Okay.
Please don't turn the page yet. It's still invisible. You have like a 30-second delay on my end. So I
Okay.
just wanted you to know that. Please don't turn the page yet.
I will not.
Thanks.
Oh, all right. Tell you what, while you're finishing up there, I'm going to just take a second and recharge my coffee cup real quick, and I'll be right back.
Thank you. Okay, I'm good.
All right, we good?
I am.
Okay. All right, so one last thing we need to talk as far as the new formula goes. One last formula. And it's going to be the compound interest formula for what we call continuous compounding. Okay. All right. Now, if you had some college algebra experience and had dealt with exponential functions and then logarithmic functions, we had dealt with number E, and we dealt with asymptotes. Mathematically, we'd be able to wrap our head around this a little better. And I'm assuming, though, we don't have those experiences. I just decided, made an executive decision as I was going through the homework that I'm going to assign. I took out the last couple problems dealt with logarithms. And as opposed to trying to teach you in the manipulation, but not really understanding, I just decided that I got rid of them. And you got enough to work on anyway. So we're not really missing out on that. But the basic idea here is that the compounding is going on constantly within a time interval. And that's where the word continuously. So it's not just like at the end of the day we compound, or at the end of a quarter we compound. It's literally every moment of time compounding is occurring. And so that is not easy to kind of wrap your head around, but mathematically we can do that. And the interest formula for that, or how much money am I going to make over a period of time, my accumulated balance. This formula is going to look like your principal, and then times, and there's the number E. Remember, it's about 2.72 to the power of the APR times the number of years which you want to leave that investment in there. All right, so you can actually write this a little more succinctly without putting in the multiplication symbols. E to the power of APR. And I do want to put a little dot there for multiplication, but that's all up in the exponent. All right, so in order to do this calculation, you have to have a calculator that has the number E on it. Now you can, if you use a scientific, get a fairly good approximation, but you need to take E out to several decimal places. So I'm going to write out to several. 2.71828, and that's all I see there. I want to actually take this out farther. 1.828. That's a lot to type in, but you could use that if you didn't have an E on your calculator. Okay. So let's do a little sample problem with this formula. Let's say you have a deposit, so your principal is going to be $100. An APR of 8%. We're going to compound continuously. We're abbreviating there. Compound continuously. And we're going to look at going for 10 years. So picking up your accumulated balance, it would be, what, 100 times E to the power of 0.08 times 10. All right. So that's going to end up giving me $222.55 over that 10-year period. I'm going to punch this one in the calculator. Uh, 0.08 times 10. Okay. So you can see the 100. Right beside the 100, you see the E. You see the caret symbol for exponent. On this calculator, when you hit E, it gives you a left parenthesis. Then you can type in the 0.08 times 10, and then I close parenthesis, and you can see that I got 222.55, and I rounded the hundreds place. All right, now let's just to compare, let's take the same amount, same APR. Let's compound it quarterly. So, but over the same specified amount of time, so 10 years. All right, so now I gotta think, remember the formula. So A will be your principal times now 1 plus 0.08 divided by the number of compounding period, which would be 4. And then up here, it's going to be 4 times the number of years, which was 10. All right, so let me pop that into my calculator. I'll have 100 times 1 plus 0.08 divided by 4, close parenthesis, to the power of, which would be 40. All right. And I get 220. 80 cents. So again, the more times you compound, the more money you make. All right, that was really the point drawn there. Any questions? Okay.
Just a second, okay?
Oh yeah. I was actually just kind of pausing there because I know you've got the delay going on. It's interesting though. It's not audio delay. It's something's going on with the whiteboard.
It's like you're writing with imaginary ink, and then 30 seconds later, it all pops up.
Oh, I think gamers call that lag.
I call it, it sucks. Okay, I'm caught up, or Olivia might not be. She's having the same issue.
Oh,
No, I'm good. I'm good.
you're good?
Okay,
All right.
good now.
Yeah.
All right. So, what I want to do now is actually go in and go through some of the actual homework problems that are going to be assigned. It was originally 32 problems in this one section. I pared that down, taking out some basic math review type problems that I just didn't think we really needed, plus some duplicate problems. Anyway, I pared it down to 19. So I cut it to 19 problems. And is quite honestly, there's some of you who are still running behind and need to get caught up. We're going to talk about that. I have kind of a plan to attack that issue too. But that being said, let me call up. All right, so number 1, number 2, number 3, number 4, number 5, 6, 7. Basically 1 through 7 is kind of just reviewing through definitions, terms, the kind of problems. It'll give you problems. I'm going to back up to I'm looking at number 7, and it asks the bank that pays the highest annual percentage rate, the highest APR, is always the best deal. And then you got 3 statements to choose from. 2 of them say don't make sense. 1 of them says the statement makes sense. So you've seen these kind of problems before. And it's just really getting at the concepts of what we're looking at. The correct choice is on this particular problem is the statement doesn't make sense. Just because the bank, you choose the bank with the highest APR does not necessarily mean that's going to be the best deal. Remember, what's really important is how many times does it compound. The more times you compound, the more money you make. So you could choose a bank with a lower APR, but if it compounds more, you're going to get that higher APY. That is, you're going to make more money. Okay, so anyway, 1 through 7 kind of just deals with concepts and terms and that sort of thing. Then you hit number 8, and now we actually start doing some calculations. So the first one just deals with simple interest. It says you invest $1,000 in an account that pays a simple interest of 2% for 30 years. How much money will you have at the end of 30 years? So what you would simply do there, where did I set this? The thing is, remember, this is this is simple interest. So you're going to make the same amount of money every year. So if you originally put in $1,000 at 2%, that's times 0.02. That's $20. Now, so basically every year for 30 years, I'm making $20. So 20 times 30 is 600. And so the amount of money I'll have after 30 years is that 600 plus the 1,000 I started with, or 1,600. Questions on that? That's just simple interest. That was number 8. All right. Number 9 now starts to compare simple interest, compounded interest. And you got to fill in a table. You've got, in this particular case, so you're not really using a formula per se. You're just figuring out how much money you're going to have at the end of year 1, year 2, year 3, year 4, year 5. Down one column, you put in the interest that you would earn every year. So, am I good to turn the page here?
Yes.
Okay. So I'm looking at number 9 on the homework at 4B. And it says we've got $4,000 that we're going to put in. So that's my principal. So P is 4,000. You have an APR 2.1%. And you're going to compare, Suzanne's going to put her $4,000 at that APR and account with simple interest. Derek's going to put it in a compound interest, and it's going to be compounded annually, but it's compounded, but annually. Now, again, if you wanted to figure out, how much you would have after 5 years, you could put it in the compound formula, and out would be, just Y would be 5. But what this is going to do, this problem does, is break it down year to year. And so you have a column here that says, so year 1, year 2, year 3, year 4, year 5. And then just use Suzanne. This will just be for Suzanne. Suzanne's annual interest. Annual interest. This is interest paid. And then balance. And this is going to be for okay. This is going to be for Suzanne. And again, that was simple interest. I'll just put the word simple here. And so your annual interest will be 4,000 times 0.021, which is $84. So if it's simple interest, then every year she just gets paid $84. That's it. Your balance, then at the end of the first year, would be 4,084. But it's just keep adding what? 84. So then you would have 4168, 4252, 4336. That is, just keep adding 84 until you arrive at 4420. All right. Then you're going to do another table. I'm running out of room here. I'm just going to do Y. 1, 2, 3, 4, 5. And my annual, and I'm going to abbreviate here, annual interest. And then I'll have my balance. And this is going to be for Derek. And this is, again, compounded annually. So remember, year 1 is going to look the same because the interest rate is going to be the same. So 1 year, it's 1,000 or 4,000 times 0.021. So it's $84 added on. But when you calculate the next year, remember now what's going to happen is it's not that flat rate, keep adding 84. You're going to then take 4,084 on your calculator, this number, times 0.021. Now, that will give you, on your calculator, just pop that in there, 4084 times 0.021. And this one tells you to round to the nearest dollar. The problem does. All right, so let's get that up there. So I would round that to 86. And so that second year, I'm actually making 86. And then you would add that to your 4084, and you go 4170. And then now third year, this number times 0.021 and round it to the nearest dollar, and it comes out 87. And then 4257. And then get the fourth year times 0.021. You would actually have $90 of interest, 4347. And then the last year, you would have earned $91 of interest. And now you got 4,438. And so the problem is really just so you can see the difference between simple and compounded, at least compounded annually. Okay. All right, so that's number 9. And this one is number 10 is it compounded annually. And so you just put into the formula, get the number. Number 11 has quarterly compounding. You're trying to, again, figure out how much money you're making after a specified period of time. We've looked at those. Number 12 deals with compounding monthly. 13 is compounded daily, so your N would be 365 in that case. And actually, let's do number 13. Let's do number 13. It's a little different. Because what number 13 is looking for is your APY. Remember that, your percentage of what you made. All right, so we're going to find our APY. In an investment, so what would be my APY if a bank offers an APR compounded daily, and I want to know what is my APY. All right. So in order to do it, given, and I did not, I apologize. I said offers an APR. I never said what it was. So the APR will be in this problem 7.1% compounded daily. And I want to figure out what my APY would be. All right. So notice when you read the problem, you're going to see a bank offers, just literally all it says is a bank offers an APR of some specified percentage compounded at, daily, monthly, quarterly. What's the APY? Notice no principal was given. No, so make up your own principal. It could be any number. Your APY will be the same no matter what the number is. So let's do 1,000. And that will be by P. All right. So 7.1% is my APR. It is compounded daily. So that's 365 to be in. All right. So to find the APY, I got to figure out how much money I'm going to make over 1 year in this situation. So I would get my formula. All right. So recall formula in general for compounding over certain number of compounding periods is P times 1 plus APR divided by N to the power of N times Y. Now, because we're trying to find my annual percentage yield in this problem, you use 1 for the year. All right, so plugging our numbers in. I would have 1,000 times 1 plus, now I would use 0.071 percentage in decimal form, divided by 365. And then up here would be 365 times 1. So it's just to the power of 365. I'll put times 1 just for the heck of it. All right. So we'd get our calculator and we'd crunch that out. And I'm going to get 1,073.57. Right. Now, so that's just how much money I would have in my account after 1 year. So now we want to find our relative increase. So again, that what we call in this situation our APY. And that's going to be your absolute increase, which would be 173.57 minus what I started with, 1,000, divided by what I started with, which was 1,000. And that's approximately 0.0736. And so as a percentage, actually, we don't need that because we rounded here to get that. But that would be 7.36. So that is your APY. And that would be your annual percentage yield no matter what you invested, how much ever you invested. You could have picked 2,000, done the same thing. Your numbers would be different, but at the end, you would end up with 7.36%. Questions on that one? Okay. Uh, 14 is also APY, just different compounding period. 15 deals with more compounding periods, different compounding periods, and your APY at the end. Okay. All right. Okay. Let's look at number 18. And am I good to turn page?
Yep.
Okay, so page 8, number 18. Still in 4B. All right, so we're going to turn this problem around a little bit. Still using what we have been learning today, but in a little different way. And this is when you do that, applying what you know to kind of a little new and different situation, that's what I call critical thinking. You are thinking critically. So this time we're going to ask the question in a little different way. So let's say I have a newborn. So I'm already thinking ahead to college. 18, 19 years down the road. And I know how much money I need to have saved up in that period of time. And I know my APR for an investment. But what I don't know is how much money should I put in the account? That is, what does P need to be in order to get to a specified amount of money? All right, so kind of flip this problem on its head. So in this particular problem, we want to know how much money do I need to deposit today? What is P? If I want to have $155,000 saved up in the account. So I want that amount in 19 years with an APR of 8.25%. Okay. So at the end of the day, what is P? That is, what will my principal have to be to attain this? Okay. Okay. So we're going to do a little bit of algebra here. It's going to look kind of funky, but we actually did this when we worked with proportions. Right. So it's going to look like this. So our formula is A times P times the quantity 1 plus AP. Oh, I should say, because what I did not say here with my APR of this, we know that we will be compounding quarterly. Got to have that information. And then to the power of n times y. Okay, so when you see this formula, it is P times and then all that. So this is just like really one thing. I could divide both sides of this equation by that one thing. And what I would arrive at is a manipulation. It's also, it's the same formula. It's just been manipulated a little bit. That is, I'm isolating P. And what I have done, again, mathematically, is I've divided both sides by this quantity. So P equals A divided by, and then all of this, 1 plus APR divided by n to the power of n times y. So what that tells me is I could now plug in everything I need, and then just do the arithmetic with this version of the formula. All right, so let's do that. And so it would look like this for this particular problem. I want my accumulated balance after 19 years to be, that is A, to be 155,000. Then it's 1 plus my APR in this problem was what, 8.25%. So that's 0.0825. We're compounding quarterly, so n is 4 to the power of 4 times, and this is going to be after 19 years. So 19. All right, so it would then be a matter of putting this into the calculator, and P is going to come out to, in rounding the hundreds place, $32,847.35. So I know, how much I would need to put in there to obtain. So I would need to start with $32,847.35. All right, let me, I'm going to punch this up because I know we got the lag anyway. So you're writing, and I'm going to punch it up in the calculator. So my TI-30XS, so we can see what it would look like. Ooh. All right. All right, bear with me here. I must have missed a number somewhere. 55000 divided by parenthesis. Parenthesis. 1 plus 0.25 divided by 4. This power of, oh, that's probably what it was right there. 4 times 19. And yeah, there we go. Sorry, I missed the button the first time. All right, so this one's a little trickier on the calculator when you enter it in. And that's the point I wanted to make here. So, all right, trying to put that up to the screen. Now, what I'm going to do is I'm going to write it down on the whiteboard here. But you can see I got the number, 32,847. But I had to be careful about grouping symbols to make sure the machine understood exactly how to do the calculation all in one step. So you can see the 155,000 divided by, but then you see two sets of parentheses, right? So, and because there's a lot going on there, you can't see the rest of it. You can see the arrow there on the end, but you can't see the rest of what I typed in. So what I'm going to do now is I'm going to actually write out exactly how I type this in the calculator. So on the calculator, it would look like this. One, I would start off by typing that. I hit the divide button. This fraction bar here, divide by. So you will see this, but I need to make sure the calculator divides this number by all of this. And so I'm going to have a parenthesis here. And after I get done typing all this, I'll put a closing right parenthesis there. And remember, with parentheses or any grouping symbols, they always come in pairs. So you never have just one. So this first one is to enclose this whole bottom. So then I know I've got that one. Now I've got this first term, which is in parentheses. That's where you saw that second parenthesis. And then I typed 1 plus 0.0825. Then I hit divide by, so you see the divide symbol, and I hit divide by 4. Then I close the parenthesis. Then I hit the exponent button. So that was the caret symbol. I've got two things here being multiplied. So I hit a parenthesis. This is what you couldn't see. Then I close that parenthesis so that it's only raising this to the power of 4 times 19. Then I close out one more parenthesis. And so those are my pairs. And so that is what I typed into the calculator for this problem. All right, so I'll let you guys catch up on the writing up there. Oh. All right. All right. Any questions?
Yep, I'm good.
Okay. All right. So I'm assigning will be 4B, homework 4B. So I guess officially titled Section 4.B homework. And there's a chapter 4 review quiz. All right. All right. So I put due dates on those. The homework is Saturday, again, just kind of pacing. And Sunday is the quiz, which then leads us into Monday. And Monday, I need to discuss with you all. So remember, you can always work past due dates. But I'm going to go ahead now. None of the questions. Close that out. And I'm going to pause.